Good morning, class. Today we are going to do the Pythagorean theorem proof by picture. Everyone knows that proofs by picture are way more fun. Let's start with some review. You should all be familiar with what the Pythagorean theorem states, and that is a squared plus b squared equals c squared. Now, what does this mean? For any given right triangle with legs A and B, the sum of the legs squared, a squared plus b squared, is equal to the hypotenuse squared, which is c squared. To start this proof, we start with two squares. Now these squares have the same area. We're going to partition these squares with lengths of a plus b, but each square will be done differently, and I will show you how. To start off, we'll focus on this brown square. So in this corner we have a, and the length of this side is a plus b, and the length of this side is also a plus b. Now when we find the area of these different segments, we end up with a square that looks like this. We have a squared and b squared here. Now these two terms should be familiar because a squared and b squared are both in our Pythagorean theorem. But we're also left with these two segments, AB and AB. So the total area of this triangle is a squared plus 2ab plus b squared. Now let's get to this yellow square. We'll partition this one a little bit differently. We'll have still lengths of side b plus a and b plus a. These lengths still equal, and still equal to the lengths of the sides of the other square. But if we section this square off, we end up with triangles. And we're going to call the length of this hypotenuse c. So in the center we have c squared, and around these edges we have extra segments. 1/2 AB is the area of each of these triangles. So in total, we have 2AB plus c squared as the area of this square. Now let's compare our squares. So on this square, we have c squared in the middle, and we have 1/2 AB as the length of those triangles. On this square, we have 2ab plus a squared plus b squared. Now we know that these squares have the same area. If we can prove that the extra segments, the AB in this square, and the triangles 1/2 AB on this square, have the same area, then we'll know that the remaining segments, a squared and b squared on this shape, and c squared on this shape, must also have the same area. We will do this by cutting the triangles off of here. I have cut the triangles off of our yellow square, and I have also cut the rectangles off of our brown square. Now you can see that if you piece them together, they are of equal area. So now we know that our remaining segments must also have the same area. And we have just proved that a squared plus b squared must be equal to c squared. Now let's explain using algebra the processes that we just went through. For our yellow square, we had said that this was equal to a squared plus b squared plus 2ab. For our brown square, we said that this was c squared plus 4 times the quantity 1/2 times the quantity AB. Now we can simplify the 4 times 1/2 AB. We'll end up with an equation that looks like this. A squared plus b squared plus 2ab equals c squared plus 2ab. Now we can quickly see that the two ABs are able to cancel each other out. Then at the end, we're left with a squared plus b squared equals c squared, proving the Pythagorean theorem.